how do we create it? Now that we understand how RAG works, let's see how we can create RAG. So the first step is to load data into RAG. This is the most crucial step in building a RAG system is preparing and loading high quality data. So the AI's ability to retrieve relevant and accurate information depends entirely on where and how this data is stored. To make retrieval efficient, we typically store data in vector databases, which allow fast and intelligent searches. But let's break it down. What kind of data do we load into RAG? We can load structured data, databases with well-organized tables, product catalogs, financial reports, or unstructured data, text-based information like PDFs, like articles, like customer chats, like medical records, or multimodal data, images, audio, video transcripts that AI can process. But how do we store this data? The most common storage method in RAG systems is vector databases, which help in efficient retrieval instead of storing raw text. These databases convert text into vector embeddings, a mathematical representation of meaning. So the first step is to import, for example, files, upload and read documents or data from external sources. The second is text chunking, which means to split long texts into smaller segments for better search. The third step is the creation of embeddings, which means conversion of text into numerical representation, into vectors. And finally, save to Astra database. Save embeddings to a vector database for quick search. These databases help the AI find the most relevant pieces of information in milliseconds. Once we have stored our data, the retriever is the component responsible for finding the most relevant pieces of information when the AI receives a query. So the retriever acts like an AI-powered librarian. Instead of searching exact keyword matches like traditional search engines, it looks for meaningful contextual matches. So how does retrieval work? First of all, a user asks a question. For example, what are the latest developments in AI ethics? Then retriever converts the question into a vector representation. Instead of just looking for the words AI ethics, it understands the meaning behind the query. So the retriever searches the vector database, finds documents, articles, or reports that contain semantically related information. Then the results are ranked based on relevance. The most useful documents are prioritized. The LLM generates an answer using the retrieved documents. The response is now based on up-to-date and accurate information. So what techniques do retrievers use? Now that we understand how RAG loads and retrieves data, let's talk about how we can actually build a RAG system efficiently. So instead of coding everything from scratch, we can use powerful open source frameworks that simplify the process. Two of the most popular tools for building RAG pipelines are LangChain and LangFlow. What is LangChain? LangChain is a Python library that allows the creation of applications based on LLMs, offering tools for query synthesis, database integration, and dialogue memory management. So LangChain is a framework designed to help developers connect LLMs with external data sources, including databases, including APIs, and retrieval systems. It acts as a middleware that organizes how an AI retrieves and processes information before generating responses. So, some key features of LangChain are document loaders, because helps ingest text from PDFs, web pages, or databases. Retrievers, integrates with vector databases like AstraDB. Memory handling, because it stores past interactions for context-aware conversations. And custom chains, allows us to define how data flows between retrieval and generation. In simple terms, LangChain helps us to create step-by-step pipeline where the AI retrieves relevant knowledge before generating responses. For example, in a chatbot, a user asks a question. LangChain triggers a retrieval process. The retriever fetches relevant documents using a vector database. The AI generates a response based on real-time retrieved data. Then LangChain makes it very easy to customize and adapt these workflows. And we have LangFlow. What is LangFlow? LangFlow is a graphical user interface for LangChain, allowing the creation and testing of no-code data processing chains. While LangChain is code-based, LangFlow is a visual, no-code tool that allows us to build and test LangChain pipelines without writing code. So LangFlow provides a drag and drop interface where we can connect LLMs, we can connect retrievers, we can connect databases. All these can be done visually. We can adjust parameters without modifying code. We can rapidly prototype and test different architectures, RAG architectures. Think of it as a flowchart builder for RAG. This is extremely useful for researchers, for developers who want to experiment with different retrieval strategies, with prompt tuning and AI workflows before deploying a final system. That we understand how RAG works and how to build it using LangFlow, let's evaluate again its strengths and its challenges. While RAG is a game-changing technology for AI, it is not a silver bullet. It comes with both advantages and limitations which we need to consider when designing real-world applications. So let's see the advantages, why RAG is a powerful solution. First of all, we have more accurate responses. Unlike traditional LLMs that rely only on their training data, RAG fetches real-time information, leading to more precise and trustworthy answers. We have up-to-date knowledge. Since RAG retrieves information from external resources, like live databases or documents, it can stay updated without requiring costly retraining of the AI model. It reduces AI hallucinations. LLMs sometimes make up information when they don't have relevant knowledge. RAG helps fix this by ensuring that responses are backed by real-world documents. And finally, we have customization for different use cases. So RAG can be tailored for specific industries, such as healthcare or finance or legal applications, where accuracy is critical and requires retrieving domain-specific information. Regarding the disadvantages, there are specific challenges, specific limitations of RAG. First of all, we have increased complexity, databases and language model integration required. So setting up RAG requires managing multiple components, LLMs, retrievers, databases, vector embeddings. Keeping the system optimized and up to date requires constant monitoring and maintenance. Then we have search time. Data recovery may take a long time in very large databases. So, unlike standard LLMs that generate responses instantly, RAG requires an extra step of searching for relevant documents, which can slow down response time and require more computing power. And of course, we need also high quality data sources. RAG is only as good as the data it retrieves. If the external database contains biased or incomplete or low quality information, the AI's responses will be equally flawed. And we have security and privacy risks. Since RAG retrieves external data, there is always a risk of leaking sensitive information or exposing confidential data sources. So proper access control and security places must be in place. When should you use RAG? So despite these challenges, RAG is an excellent choice when accuracy is critical, like medical, legal, financial applications, when up-to-date knowledge is required, like news summarization or academic research, when we need to reduce AI hallucinations, for example, customer support, enterprise AI systems. If you just need, however, just a general purpose AI assistant, a standard LLM without RAG might be a simpler and much more efficient choice. With RAG, we are moving towards AI systems that are truly dynamic, that are truly reliable, and truly intelligent. Now, let's see how we can install LangFlow and use it.